Hello, and welcome to the video on sensation and perception. Today we're going to talk about general information on sensation, perception, and how our senses work, and the basics of Gestalt theory. We should be able to, after today, recognize the role our senses play in sensation and perception, and understand how Gestalt theories are integrated into many things we see every day. So first, let's talk about the difference between sensation and perception. Sensation is the process that occurs when special receptors in our sense organs are activated by information from the outside environment. Our sense organs are our eyes, ears, taste buds, nose, and skin. Sensation turns information from the outside world into signals that can be used by our nervous system, which includes our brain. Perception is the process of interpreting those sensations. So sensation takes in information from the outside environment, and perception is our brain making sense of that information and using it to make decisions about responding. So sensation occurs when specialized neurons or sensory receptors in each of our sense organs are activated by different types of information. And these sensory receptors are located basically all over us, our skin, our ears, our nose, our eyes, and our taste buds. Our skin is activated by pressure and temperature. Our ears are activated by vibrations. Our eyes are activated by light or lack of light, and our nose is activated by scent, which is actually when we breathe in tiny molecules. Our taste buds are activated by sweet, sour, salty, bitter, and savory flavors. So here we'll talk briefly about sensation and absolute thresholds. So an absolute threshold is the lowest level of stimulation a person can consciously detect and correctly report noticing at least 50% of the time. So let's go over these examples and kind of discuss this. So for sight, we can see a candle flame at 30 miles distant on a clear, dark night. So what that's saying is that 31, 32 miles, most people aren't going to see that light, but for the majority of people, at least half of the time, 30 miles away from us on a clear, dark night, we could in fact identify a candle flame or a light of some kind at 30 miles away. So that being the absolute threshold means that is the lowest level, like the smallest light, the furthest distance away, that at least 50% of people are going to be able to see it. So with hearing, it's the tick of a watch 20 feet away in a quiet room. With smell, it's one drop of perfume diffused throughout a 3-room apartment. For taste, it's 1 teaspoon of sugar in 2 gallons of water. And for touch, it's something as light as a bee's wing falling on our cheek from 1 centimeter above. So if you think about this, I think we're almost like superheroes. We do a pretty good job, our senses do a pretty good job interpreting the world around us. So subliminal stimuli is a stimulation that is not consciously detected, but is strong enough to activate some sensory receptors. For example, if you're watching a commercial and they try to sell you a beverage, or they talk about a beverage, if the target, if you, are thirsty, then a subliminal stimulus for a drink is likely to influence you to purchase the drink if the drink is available and you're thirsty. But the stimulus can also, or the stimuli can also influence us to choose the primed option over other habitually chosen options. Say you always get the same brand of the same thing, but if you see this stimuli for a different brand and that other brand is available, you may decide to get it. So, however, we do have to understand that subliminal stimulus does not work on people who do not want the thing they're being prompted to do, or they don't want to do the thing. So, for example, if you are not thirsty and you are seeing an advertisement for a specific brand of water, you are not going to care. It doesn't matter. It doesn't work on you. It doesn't work on everybody 100% of the time. They just kind of bet that some people watching their commercial are going to be thirsty, right? So on those people, that subliminal stimuli could work. There's an article here linked in the slides. So habituation and sensory adaptation. We only have a limited amount of attention to give to any one thing, which we talk about in another module, but for now, just understand this means our brains can learn to tune out things that become constant. So habituation is sensory receptors still activate, but our lower brain areas filter out unchanging stimuli so that all information does not need to be processed at the cortex. And what is the cortex? That's the wrinkly outside portion of the brain that is responsible for conscious thought and language. I say it's like the complicated thought area. So it's not basic, like I'm cold, I'm hot, I'm hungry, I'm thirsty. The cortex is like our decision making, our complex thought, our complex decision making, all of that. So speaking more about habituation and sensory adaptation, you may have experienced habituation if you live near a train station, airport, or fire station. When you first moved in, you might have noticed trains, airplanes, fire trucks, all of that all the time. Really loud, really intrusive. But after a few weeks or months, you might not notice them so much anymore. Sensory adaptation is when our receptor cells become less responsive to a stimulus that is constant or unchanging. So an example of this might be a candle or a bath product store. When you first walk in, you can be very overwhelmed by the wall of smell that is coming at you. But after some time, you may be able to wander around the store and not feel so overwhelmed by all of the strong scents. So you your brain kind of understands, okay, we're fine. It's a candle store. We just have to like manage, right? So habituation and sensory adaptation both allow the brain to ignore things it doesn't need to focus on. So this leaves us more thinking power for other tasks. So this part of the class, I showed this video that is a clip of a Febreze commercial identifying how people can become nose blind. And it's kind of a funny clip. I will link it below. So in that previous slide, we saw how he just got used to the smell of his cooking and the fish, and the wife was like, no, we're not all used to it, right? So they promoted that maybe he was adapting or becoming numb kind of to that smell, whereas everybody else was not. So, okay, the senses. Let's talk about sight. So sensory receptors in the eyes respond to light waves. Light waves have properties such as amplitude and wavelength. Amplitude is how high or low the peak of a wave is, and determines how bright the light is. Wavelength is the distance between peaks of the wave, and this determines the color of the light. If you'd like to learn more about waves and visible light, there is a link that I will attach below talking about colors of light. So the visible spectrum, which we saw on the previous slide, shows the wavelengths of each of the component colors. The spectrum ranges from dark red at 700 to violet at 400. Visible light is the small part of the electromagnetic spectrum that human eyes are sensitive to and can detect. Visible light waves consist of different wavelengths. The color of visible light depends on its wavelength. These wavelengths range from 700 at the red end of the spectrum to 400 at the violet end. Visible light waves are the only electromagnetic waves we can see. We see these waves as the colors of the rainbow. Each color has a different wavelength. Red has the longest wavelength and violet has the shortest. When all the waves are seen together, they make white light. Colors of objects appear in different colors because they absorb some colors or wavelengths and reflect or transmit other colors. The colors we see are the wavelengths that are reflected or transmitted. For example, a red shirt looks red because the dye molecules in the fabric have absorbed the wavelengths of light from the violet or blue end of the spectrum. Red light is the only light that is reflected from the shirt. If only blue light is shown onto a red shirt, the shirt would appear black because the blue would be absorbed and there would be no red light to be reflected. White objects appear white because they reflect all colors, and black objects absorb all colors, so no light is reflected. Color detection. The retina of our eyes contains two types of photoreceptors, rods and cones. The cones detect color. The rods only let us see things in black, white, and gray. Our cones only work when the light is bright enough, but not when the light is very dim. This is why things look gray and we cannot see colors at night when the light is very dim. This video will be linked below. Sight, or parts of the eye. Let's talk about it. So there's a diagram site linked here, which will be, again, linked below. But the cornea is a clear protective membrane that covers the eye and helps to focus the light coming in. The pupil is the dark circle in the center of the eye, an opening in the eye that lets light in. The iris is the colored part of your eye around the pupil. This is actually a muscle that can change the size of the pupil to allow in more or less light. The lens is behind the iris. It further helps to focus the incoming image and project that image onto the retina. The retina contains sensory receptors, rods, and cones. The rods are responsible for non-color vision in low levels of light and for peripheral vision, or vision kind of to the sides from middle. They tend to produce vision that is fuzzy and not sharp. Cones are responsible for color vision, seeing in brighter light. Rods and cones convert incoming light information into a signal that can be sent to the brain. Also, pro tip if you'd like a hint for trying to keep the rods and cones straight, remember cones and color both begin with C. For hearing, here's some parts of the ear. So the outer ear includes your pinna and ear canal. So the pinna is the part of your ear that you see on the sides of your head. It is cartilage and soft tissue. It is not bone. This helps it keep its shape, but also to stay flexible. Sounds go in and down your ear canal. This helps you figure out which direction the sounds are coming from. The middle ear is where your eardrum is located, kind of at the end of your ear canal. This is where your middle ear starts. Your middle ear has 3 tiny bones in it called ossicles. These 3 bones form a chain from the eardrum to the inner ear. The eardrum moves back and forth when sounds hit. Different pitches, or how high or low a sound is, make the eardrum move more or less. So the eardrum makes the small bones move, and the movement sends a signal to the inner ear. Your inner ear helps with both hearing and balance. The cochlea is the hearing part of the inner ear. The semicircular canals are part of your balance system. The cochlea is bony and looks like a snail. It has fluid and hair cells inside of it. When the bones in your middle ear move, the fluid in your inner ear starts to move. This movement triggers the hair cells. Not all hair cells move at the same time. Different hair cells move for different sounds. The hair cells change the movement into electrical signals. These signals go through your auditory nerve into your brain. Your brain understands these electrical signals as sounds. Your brain then has to figure out what the sounds mean and how to respond. This is how we hear. Your inner ear also helps control your balance. The parts of your inner ear that help with balance share the same space and fluid as the cochlea. These parts are the semicircular canals, the utricle, and the saccule. Sensory receptors respond to sound waves, also characterized by wavelength and amplitude. The wavelength determines pitch, and the amplitude determines volume. We hear by the anatomy of the ear, guiding sound waves to the receptors. They vibrate parts of the ear, and that sends messages to the brain. The pinna is the visible part of the ear. It acts as a funnel for sound waves, directing them to the eardrum, which vibrates. The eardrum vibrates, causing the bones of the middle ear to vibrate, which causes the inner ear to vibrate. The cochlea, or the inner ear, houses the basilar membrane and the organ of Corti. Fluid in the cochlea moves with vibrations, causes movements of the basilar membrane and the organ of Corti. So this moves, and the hair cells inside this organ bend, sending messages to the brain. Information on volume and pitch comes from the vibrations or loud sounds. So loud sounds can damage the bones and the hairs and cause hearing loss. Here's a video that I will link below of a visual of kind of how sound comes into the ear canal and creates those nerves, those nerve activations. Taste and gustation, or gustation, how we taste things. Taste buds have receptors for our sense of taste. Sweet, sour, salty, bitter, and umami, or savory, are the 5 basic tastes. If you picture a diagram of the tongue with different taste abilities located in different areas on the surface of the tongue, this is no longer the most accurate way to think about how we taste. Receptors for basic tastes are all over. They're all over the tongue, the cheeks, and the roof of the mouth. What we think of as taste or flavor is impacted by a variety of things, including temperature of the food, texture, and our sense of smell. So here we take a class poll and we think about what flavors are our favorites: salt, sweet, savory, what are favorite foods, what are least favorite foods. And usually it's an interesting combination of things. There's usually trends towards salty, sweet, and savory in different groups. And then as far as favorites and least favorites, some people's favorites are the least favorite of other people. So the point of this question to the class is to kind of show everyone how large the spectrum is when how we feel about different flavors and favorite or least favorite foods. So now we'll talk about smell or olfaction, how we smell things. The top of the nasal passage has receptors for our sense of smell. Tiny molecules of the substance we're smelling fit into those receptors and send a message to our brain. Science currently says that humans have at least 1,000 different types of smell receptors. A sense of smell is impacted by things like age, gender, culture, and can be damaged by certain illnesses. One example I like to talk about here is how my partner had COVID. And since COVID, he's had limited ability to smell sometimes. Sometimes it's totally normal. He smells all the things, cooking, whatever, all of those normal smells. Then other times, he smells nothing. It's really strange. He'll come into the house or the kitchen and say, "Oh, you're cooking? I didn't even know." So it's really interesting how viruses or other illnesses can impact our ability to smell. So also the way that we smell things, or our ability to smell, tends to decline with age, and women tend to have a more sensitive sense of smell than men do. Smell identification tests show that culture and socioeconomic background can affect what smells people can correctly label and identify. Pheromones, or chemical messengers, are released by an animal that affect the behavior of other animals. Some pheromones in animals affect attraction and sexual behavior. Here we take another class poll and we talk about what smells are our favorites. Also, do we have least favorite smells? And again, here the trend is interesting. Some people appreciate sweet smells or different types of categories of smell. Well, those are the least favorite for others. So this is a very individual thing. Most people can say, "Oh, vanilla is pleasant," or fresh laundry is pleasant. But some people think that the smell of flowers is nice, and other people despise the smell of flowers. So it really kind of depends on the individual. So here we'll talk about a t-shirt study that happened. So in one set of study, participants were asked to wear a plain white t-shirt to bed each night for a period of time. They were given very specific instructions about what soaps and deodorants to use. At the end of the study, they returned the t-shirt to the laboratory. So basically, they weren't using any scented soaps or deodorants. It was just the person wearing the shirt to bed each night for a period of time. Then they took this shirt and returned it to the lab. A separate group of participants was then asked to smell each t-shirt and make ratings of the attractiveness of the person who wore the shirt. The only information these participants had was the scent of the shirts. They did not get to see photographs of the other participants. It was just the shirt and that's it. So these studies have been done with photos, and those studies have shown that we tend to prefer the scent of attractive people and people with symmetrical faces. But this study that we're talking about right now, no photographs, just shirts. So women were also attracted to men with the most different adaptive immune systems from their own. So they were able to determine this, the smell of the t-shirt. Of course, this wasn't a conscious thing, but they found after people determined, okay, shirt A or shirt C or shirt F, these shirts were the ones that were most attractive to to specific women. And those women were tested, and the people donating the shirts or doing the shirt part of the experiment also were tested, and they found that with no other information at all about this other human, they were attracted to the people that had the most different or unique immune system cells from their own. That's so cool. It's like, as people, we're really trying to survive, right? So this is a super interesting thing, I think. So that's why I share this study. Next, we'll talk about touch, or how we feel things. Our skin senses. This allows us to detect pressure, temperature, and pain. There's many nerve endings in the skin. The kinesthetic sense is the receptors in muscles, joints, and tendons that tell us where we are in space and where we are in relation to our parts. Even in the dark, you do have an idea of where your limbs are. Also, we have a vestibular sense. This gives information on the position of our body relative to the ground and the space around our head. It gives us our sense of balance. Our ears have tiny fluid-filled sacs that let our brain know if we are turning quickly or spinning and when we stop. Sometimes we stop moving our body and the fluid is still moving in the inner ear in the circular canals due to the momentum that our body had when we were moving. So this causes dizziness. So perception is the way the brain organizes, interprets, and deciphers the meaning of different sensations. So although there are individual differences in perception, there are general similarities in how people perceive things. So Gestalt psychology focuses on how people perceive patterns and whole figures. It argues that people perceive whole patterns rather than just individual pieces within the pattern. And this recognition of patterns tends to be pretty universal. So these principles have helped to identify some commonalities in the way people perceive patterns. Some of these that we'll talk about today, and there's a lot, there's more than this, but the ones we're going to go over are figure ground, proximity, closure, similarity, continuation, symmetry and order, and then I think we also talk about simplicity, and then some other Gestalt principles include common fate, like if it moves like a group, it must be a group. Pragnaz, we simplify to understand, and regularity, so sorting things into groups. An example of common fate, moves like a group, must be a group, would be something like, say you were walking in the park and you saw a group of 10 or 15 runners kind of together, loosely grouped together, and then you saw 3 runners that were maybe like 3 or 4 yards behind that big group. You might say, oh, they're probably just a little behind, but they're with that group. And maybe they really had nothing to do with each other. They're just running in the park in separate groups. But our brain tends to go, oh yeah, they're probably with those people. We need to kind of identify and simplify the things that are happening in a situation so we can think about other things. So when we talk about figure ground, this is when we look at something when we separate out a foreground or figure and a background or ground. So the foreground is usually the main subject on which we will subsequently focus, while the background is generally ignored. You can see in this picture on the left, you can look at this and you might see 2 faces or you might see a vase. It kind of depends on what you're looking at, but the vase should pop out right away or the faces should pop out right away, but the difference is what's important. Areas which stand out are more likely to be seen as the foreground figure. So it could be the vase because our eyes are more sensitive to saturated or bright colors. There's a high contrast between the foreground and the background, there's a lower contrast between sections of the foreground, and there's a contrasting outline separating it from the background. The foreground is smaller than the background, which kind of surrounds it, and areas that recede are more likely to be background using colors the eye is less sensitive to, like blue or purple or unsaturated pale or pastel colors. So when we consider figure ground, when creating visual images for display, we want to ensure it's easy for viewers to distinguish the figure that you want them to pay attention to. So when making color choices or contrast choices for announcements, flyers, whatever might pertain to your work in the future, make sure the figure is clear and distinct and standing out from the background. Here's another example of figure ground. Also, in the FedEx logo, if you look at the negative space between the E and the X, you can see an arrow. This shape gives a sense of motion and direction that makes sense for a shipping company that prioritizes speed like FedEx, or claims they do anyways, right? So really, this arrow isn't even there, but because of the bright color surrounding it, it kind of pops out as a shape. Here is the Pittsburgh Zoo and Aquarium logo, and you can see how there's a gorilla and a lion in the tree. So whether you're looking at the tree or whether you're noticing the faces of the gorilla and the lion, it's kind of an interesting play on graphic. Here, the Hope for African Children Initiative logo looks like the continent of Africa, and you can see two faces. Perhaps one is a child, one is an adult, and they're kind of promoting their cause. Then the Bronx Zoo has a couple of different logos that show part of the skyline in between the legs of the animals. Here's another example of that with the Statue of Liberty right there and other important landmarks. Then here, the Spartan Golf Club logo shows what looks like a person hitting a golf ball. But if you look carefully, also the elbow of that golfer is the nose of a Spartan. And the space in between the hand and the shoulder looks like an eye. And the swing of the golf club looks like the top part of a Spartan helmet. So they're kind of using this space difference or this color difference to show two different pictures at once. Here's a couple of different examples. Yoga Australia has the shape of Australia in the yoga pose. The piano forest looks like a forest, but could also definitely be piano keys. Zip has a zipper in the middle. 8 is made out of all numbers, the number 8, but broken up into pieces. Mo Sleep is a bed. And then the hands are making eyes, the eyes of an owl. So proximity is the next thing we'll talk about. This is things that are close together go together. So when visually distinguishing different things, if a group of objects are close together, we guess that they are part of a larger whole. The reverse is also true. If things are physically separated, we assume they are not related, or at least the relationship is not as strong as the other group. So this example to the right shows that although there are some different colored figures in the larger group, they're all stacked and kind of close together. Whereas the other group there's a little bit of separation there. So we tend to look at this group that is more diverse on this side as a group, one group, whereas the other side we think of as separate, even though there are some different colors in that left-hand side. So the closest of the circles in A may well lead them to be seen as a single group, while the two columns that are separated, as in B and C, show them as two separate groups. Ideally, an object has an outline, but this is not always true. In the image below, you may be able to see a Dalmatian dog sniffing the ground in the dappled light below a tree. When there is no outline, we use both the closeness and separation of shapes contained within the item to help spot the larger shape. Here I've circled the outline of the dog to help you out if you weren't able to see it before then. The head is down and to the left, then you can see kind of the front legs, and then the back legs are a little bit more vague. So with proximity, if you want something to appear as a single item, put its parts close together. So in an advertisement, you might want to put positive images closer to your product. Using outlines and obvious spacing can help define what groups of things you want to be visualized together. Here, also you can probably see image A as one block of dots and image B as 3 columns. When used in web design, this principle shows a sense of commonality. For instance, security and application icons are grouped on the Google Workspace landing page, so people understand very quickly these images are related. So with similarity, when grouping items, we tend to put together similar things. We group items based on visual attributes such as shape, size, color, saturation, and texture. Grouped items are then assumed to be a single, larger whole. So A may be seen as a single collective shape, as all subparts are circles. B might be divided into 2 vertical columns, one of circles and the other of triangles. So when seeking to understand our environment, we first identify atomic shapes and then cluster them together into larger, nameable objects. Similarity is a simple rule that we use in this. The basic assumption is that visually similar things also have other similarities, so they belong in the same group. Similarity also appears as a principle when we're wondering if we should trust other people. If they are similar to us, for example with similar heritage, we may be more likely to trust them. Confidence tricksters use this principle when they dress and act in similar ways to people we trust, from clerics or priests or religious leadership to other leaders in the community. Here on the right, I have a picture of some trees showing the law of similarity. So basically, they could all be the same type of trees, but they look very different because the light is hitting them differently. It makes it look like there's 2 groups. Here, these are kind of the be careful with these because as we read them, we're going to notice the labels are on the wrong blocks. So the point of this is to kind of show us how quickly we group things together. So on this first one with the blue shapes, it says similarity based on shape, but those are not all the same shapes. There's some squares, there's some other shapes, they're all mixed up. Then if we look down to the bottom, there's green triangles and pink triangles. They're all the same shape, but it says the similarity is based on color, so that's switched. Then on the right hand side, we see the orange circles, and it says similarity based on size, but in fact, none of them are the same size. So it's kind of messing with us, right? So as you read the labels, it's kind of a way to kind of trick your brain and make you really think about what you're seeing is grouped together. So if you want people to see things as being the same, then use similarity in some way. You can connect things through a wide variety of attributes. Once you have connected things with real similarities, people may assume they have other similarities. So this extension of belief may go unchallenged. So considering this image, you may see alternating rows of different colored dots rather than one block of dots because of the 2 different colors. If the dots were all different colors, you might not see the image in the same way. If they were all varied colors, you might just say, oh, it's a one connected box of all different colors. You can see this principle frequently in website navigation menus. So for example, on the version of Zoom's homepage that I took this screenshot from, all the links that take users to the app are blue, where the links that are related more to customer processes are gray. So without even realizing it, the color differentiation signals that these links have different functions. So continuation is the next principle we're going to talk about. When we see a line, our eyes tend to follow it. When the line ends, our eyes keep on moving in the direction that the line is going. This also happens when lines intersect. If 2 lines cross, we tend to see it as 2 lines, rather than 4 lines that join at a single point. The eyes will tend to follow the line below, down and up on the other side, and then shoot off at the end a bit like a ski jump. So a question in any visual image, particularly when you're trying to use it for persuasion, is where is the viewer's eye going? One of the basic dynamics is that the eye tends to find and follow lines. One reason for this is to trace outlines and distinguish objects. We can recognize and name them, and we can respond to them appropriately. We tend to visually follow straight lines in particular. If you see a photo of a road, your eye will travel down the road into the distance. Curves take more work, and squiggles are a more difficult skill. Sharp angles are the worst, as the eye has to sharply change direction in order to follow them. So here is an example of the Coca-Cola logo. It's very flowy. The lines kind of continue and the shapes continue one to the other. It kind of draws the eye from the beginning to the end. Here's a logo for Houston Community College, and basically you can see the tail of behind the bird, like the swoop of wind, draws your eye through the logo and up to where the bird is going. So we perceive objects arranged in a continuous line or curves as more related than elements on a jagged or broken line. For example, you likely see two overlapping lines, not four meeting in the middle in this example image. Here is not my Pinterest, but a generic Pinterest from Google. This is Pinterest home feed interface. And while the images on the screen are all different sizes, they are arranged in columns which create unbroken vertical lines of negative space between each of the pictures. So the continuity principle drives users to scroll up and down through the app, as the vertical column layout encourages vertical movement. So when creating persuasive images, consider the locus of travel of the eye. Use lines to guide the eye appropriately. Remember to use straight or gently curving lines rather than zigzags or scribbles, and minimize lines that cross each other. So closure is another concept we're going to talk about. Given incomplete information, we tend to seek completion. So filling in the bits which don't exist. In images, this includes the extension of lines to form an unbroken outline of an object. Here, you may see 4 circles. Even with less and less information given to us with fewer lines, circles may still be perceived. Although, if you looked at D all by itself, you might not see it as a circle at first. It might be a little more challenging. You'd probably still get there. When looking at things in the real world, they might be partially obscured, such as when a person is standing behind someone else. We still need to recognize and name them as a person, so we develop this ability to complete incomplete images. We do this in the process of recognition through pattern matching. When we see something that is good enough, we match it to patterns we have in our memory, and our minds fill in the gaps and tell us that it's a complete object. This is often very helpful, although it can lead to confusion when the assumed shape is not what we thought it was. A force that creates this is the need for completion, where we feel uncomfortable until those uncertainties are resolved. This drives us to fill in the detail. Some recognizable logos apply this principle. Here for IBM, really this is just a stack of lines, but the way they're sorted out and that negative space creates us filling in the blanks to make the letters IBM. Then with NBC, there's no actual peacock here. It is the lack of color in that space and the way the other colors are arranged that make it look like there's a peacock. Then here with the Adobe symbol, this is not actually an A, it's just shapes that make it look like the blank space is an A, so we connect the dots. Also with USA Network, there is no S. It's just a really funny U and a really funny A. And that combined with the negative space looking like an S, we fill in the blank and we say, oh yeah, that's USA Network. Here, the Toblerone is a candy or a chocolate, and this has a bear in the mountain. And the bear is formed by the negative space where the yellow of the mountain is missing, or the gold of the mountain is missing. So with closure, it is possible to show partial information and let people fill in the details. You can combine simplicity with a richer implied detail. It also might be useful to play at the edge of recognition, creating deliberate confusion that makes the other person more open to suggestion. So this is also a common feature in web design. For example, when you see a partial image above the fold on a screen, like the pink image on Markup's homepage, your brain wants to complete it by viewing the whole picture. This unconsciously drives you to scroll down the page. Symmetry and order are the next principle we're going to talk about. When we see symmetry, we assume there is some connection between the two parts. We may assume that each of the two parts is a coherent whole. In symmetry, shapes have an axis, or the axis of symmetry, either side of which is a mirror image of the other. This axis can be at any angle, but it's most often vertical or horizontal. Symmetry is a form of similarity that leads us to connect two parts, creating them either as a single object or with one as a reflection of the other. Symmetry creates a pleasing balance where one side of the image matches the other. Reversal of the shape is the same but not the same, so it creates both harmony and tension. Symmetry is a form of order, which helps us to feel good at discovering regular patterns. This boosts our sense of control, as finding patterns often means being able to predict how things are. As a recognized pattern, symmetrical foregrounds stand out as against an asymmetrical background. Here you can see the Sun Microsystems logo as an example, and basically there are no S's and there are no N's technically. There's just a bunch of U's, but they're arranged in such a way that it looks like SUN across the top, across the diagonal going down to the right, and it's just interesting, right? Because it doesn't have the actual letter, but it implies the letter, and that is enough for us because we want to find symmetry. So using symmetry to draw attention to things is helpful if you want people to focus on that thing, making the background as asymmetrical or plain as possible to exaggerate the effect. We perceive and interpret ambiguous or complex images in the simplest form possible. In this example, you are more likely to see the left image as a simple circle, square, triangle than the image on the right because the three simpler shapes make more sense to your brain than the original ones. Here is another option, another example of simplicity in the Olympic rings, the Apple logo, and this very interesting, I think, McDonald's ad for Wi-Fi. So they don't really say very much, right? They have the colors of McDonald's as the basis of the page or the ad, and then they do have their logo down on the right-hand side, but it's really small. The focus is not the logo. The focus of this is the colors of McDonald's and their infamous French fries in the shape of a Wi-Fi symbol. How cool. I'm not a super fan of the unhealthy level of unhealthy that their food is, but their French fries are pretty good, right? So anyhow, this draws attention to the ad and doesn't have to say much to be able to say everything. So now we're going to go over a few different perceptual illusions, kind of for fun, and how our eyes tend to trick our mind. And this is based on the principle that we want to make sense out of the things that we see. So when something is not right or weird about it, we want to figure it out. So an illusion is a perception that does not correspond to reality. These illusions include visual stimuli that kind of fool our eyes. Psychologists are interested in studying this because it provides information about how sensory receptors and systems work. Now, a word of warning, the next two slides show still pictures that look like they're moving. So they're not really moving, but they look like they're moving after you look at them for a few seconds. So if you think you may be prone to motion sickness or that might be something that bothers you, just go ahead and fast forward through that part. So here's the first one. This is a still picture, it's not moving, but if you look at it for long enough, it almost looks like the outside, say we're in this room, right, this blue room with these orange ovals, If we look at the center long enough, it makes it look like the room is revolving around this center pillar. It's so strange, isn't it? Because I can promise you it's not a video, it's not moving, it is a still picture, but if you kind of look at the center, or even look at the sides, it kind of makes it look like it's rotating. Now let's go on to the next one. For this picture, we're looking at either lemons or limes on a blue background. And again, I promise you, it's not moving. It just looks like it is. Because of the flowy shapes of the lemons or limes against the background of blue, it looks like it's kind of waving. It's very eerie. It is kind of cool though, so I wanted to give this as another example. So in this picture by Robert Gonzalez, basically you can see what looks like a bridge coming across the water from the distance. But if you look at the right-hand side, it's a series of ships following each other across the ocean or across the water. So also interesting is that the ships, if you follow them back, the body of the ship, or the main part of the ship, not the sails, turns into the landscape that the bridge is coming out of. And the pylons, or the structure of the bridge, turns into the spaces in between the ships. Very interesting to see. Here, this one's a little weird. Same author, or same artist. Here we see kids riding a bike down a street. But when you look down, it looks like the people that there is also people on a lower level on the street, and there's big trees. If you focus on the person on the bike at the bottom of the screen or the bottom of the picture, that person is traveling down a fall street. Cool. But then you realize there's kids in the trees, which are connected to the same street, right? So kind of nonsensical, but also interesting. Here is another example, same artist. This looks like kids playing in a backyard, except the fence is as tall as skyscrapers in the front, but in the back, it's just a normal backyard, or kind of, right? So go ahead and examine this photo and see where it looks like the kids are walking across what looks like 2x4s onto this super tall fence, but then again, as they go towards the back, it's more of a regular yard. Then the last one, same artist. It looks like a waterfall coming through some rocks, but then those rocks turn into what looks like a building, or a building being built, and the people are working on the building, and they're made of the water, right? They're not actually made of the water, but the water turns into their robes. So another interesting play on perspective. So this concludes the lecture on sensation and perception. Please always reach out if you have any questions, and I will see you in class.